Hello, this is Jennifer Martinez. In this video, we're going to go over verifying fundamental identities. I have attached a table from the book on the fundamental identities. We're going to talk about the first three in this video. So the first one is called the reciprocal identities. We have been working with these since chapter 1. We know that cotangent equals 1 over tangent. Secant is 1 over cosine. And cosecant we know is 1 over sine. You need to get these memorized. I will show you how to get the first one. And I'm going to start with the right side, 1 over tangent of theta. We're going to use the definition in the very first chapter of tangent. We know that that is y over x. That's how you prove the fundamental identities, is you use the definition of the trigonometric functions. This is the same as saying 1 divided by y over x, and when we know we multiply fractions, we flip the second one, so that's 1 over 1 times x over y, which is equal to x over y, which is cotangent of theta. Then next are the quotient identities. We know that tangent is sine over cosine. Then cotangent makes sense since it's the reciprocal of each other, is the opposite, cosine over sine. Again, you need to get these memorized as well. To prove this one, I'm going to start with the right side again, the more complicated side. And by definition of sine from the very first chapter, we know that's y over r. And cosine we know is x over r. And what I'm going to do is I'm going to simplify this by multiplying top and bottom by r to get rid of the fraction, and we end up with y over x. Y over x, again, we know is tangent. So that shows the second one. By the way, you could have also done this way, y over r divided by x over r, which equals, by the way, y over r times r over x, and the r's would cancel as well. So we could have done it the way we did the first one. Erasing that scratch, let's go to the final Pythagorean. Oh, and by the way, I should circle that. I proved that one. The first is sine squared plus cosine squared equals 1. And again, we have done that in the first chapter as well. And we actually proved it back then. Let's go to it again. By definition of sine of theta, we know sine is y over r again in chapter 1. Cosine is x over r. This time I'm starting with the left-hand side. So that would be equal to, so I can actually erase this 1 here. That would be equal to y squared over r squared plus x squared over r squared, which, by the way, is y squared plus x squared over r squared. And since we are dealing with a right triangle with all these, with the trig identities, we know that from the Pythagorean theorem, that's why it's called the Pythagorean identity, that x squared plus y squared we know is r squared. So this is equal to, let's do it over here, r squared over r squared, which is indeed 1. So that proves that sine squared plus cosine squared equals 1. To prove the other two. Now what I'm going to do to prove the other two, instead of using identities, I'm going to use the fact that I've already proved this. So now if I want to prove that the second one, what I'm going to do is I'm going to divide everything by cosine squared. And what you get is tangent squared plus, because sine over cosine, we know from the quotient identities is tangent, and since we have squared, I'm going to call it tangent squared, plus 1 equals secant squared, which is another identity you need to memorize, or at least be able to get like I did. To get finally the last one, so that's doing that one, finally to get the last one, what I'm going to do is the same thing. I'm going to start with sine squared plus cosine squared. This time I'm going to divide everything by sine squared and see what happens. And what do I get? Now we get a 1 plus cosine over sine. Cosine of sine we know is cotangent, so that would be cotangent squared of theta. 1 over sine we know from the reciprocal identities is cosecant of theta. We need a squared there. That is the last of the Pythagorean. So, to be honest, I usually just memorize this and I derive these every time I need them. But you do need to get all these identities down.